Hello and welcome to what I hope will be a fun explanation of horsepower and torque in engines. First we'll do a quick refresher on what torque is. Torque is a measurement of twisting force. In order to turn a bolt, you apply a force through a wrench which acts as a lever. This creates a torque on the bolt equal to the force applied to the lever times the distance the lever extends from the rotational axis. If I add some more visuals, you can see that this also applies to the combustion chamber in a vehicle's engine. The combustion of fuel in the chamber applies a force to the piston and by extension a torque to the crankshaft, the output of the engine. If we measure the total torque on the crankshaft or at the car's wheels, we can use it to find horsepower. Horsepower is just a unit to measure power, that is work over time. So if we take the torque, multiply it by the number of engine revolutions per unit time, we get horsepower, after doing all the messy unit conversions. And that's all fine and good, but what might this look like in the real world? Well, not quite the real world, but the coolest I can do. Just under the top of the steering wheel you can see the car is a display that shows the horsepower curve of the car. The bottom axis is the engine RPM and the height represents the power output of the engine. In this car and in general, the horsepower will quickly increase to a maximum, level off, and then slightly dip down as the maximum RPM is reached. If we look back at our equation, this must mean that the torque curve reaches a maximum much earlier than the horsepower curve, and then decreases significantly. Online I found the torque and horsepower curves for this car and roughly replicated them here. The curves look as expected from our understanding of the relationship between horsepower, torque, and RPM. Well, I hope if nothing else you enjoyed the video, and thank you for watching.
Left, don't cut. Into 3 right, into caution, don't cut, 3 left.